Okay, evaporative emission controls. Let me see. Not tested vacuum. Not tested vacuum control. No testing. I don't know what that means. Not enhanced. Mostly electronically controlled. Only test for airflow. That's prior to 1996 or 94. Enhanced electronically controlled. Test for flow and system sealing leaks. Remember, 1996 and newer had to check for leaks. Here's a, this is not tested. Here's the early EVAP system, vacuum control. Here's the EVAP canister. Remember, the main job of the EVAP canister is to store vapors. Here's the gas tank. That's the pump. Gas cap is part of the EVAP system. Vapor line. It stores vapors when the car is off in the canister. At cruise speeds, the purge valve opens and it purges the vapors into the intake to be burnt again. Okay, and this old model, you can see also from the carburetor bowl vent, it stores vapors here when the car is off, and from the gas tank when the car is off. And during purging, it purges out into the intake to be burned. It only purges at cruise speeds also. Here's a charcoal canister, carbon filters or granules inside of it, the purge valve control, dust cap, fresh air inlet. Fresh air usually comes up through the bottom. On this one, it's coming from the top. Air is coming in, help push the vapors out into the purge system to be burned. So we have an open vent here to let the vapors go in, and help push the vapors out that was stored in the canister. Vacuum purge valve. Here's a purge valve in this model. Here's a thermal vacuum switch that only lets the car purge when it enters at normal operating temperature. Again, this is an older model. Here's the EVAP canister, your gas tank, that stores the vapors inside the canister. Thermal valve, I guess it's a canister valve, purge valve. Oh, what is this one? It's a canister control valve. And look at this. You see this vacuum line right here? Most canisters only work at cruise speeds. At idle, the throttle plate is closed. At cruise speeds, you get ported vacuum, the throttle opens up. The vacuum under here will send a signal vacuum to this purge valve. That purge valve, in turn, remove the vapors from the canister. It will open up, then it removes the vapors from the canister to be burnt inside the intake manifold. Enhanced systems. Now, the enhanced system has a vent solenoid. Use it somewhere near the canister. This vent solenoid and this fresh air tube is the same, but on this car, it's on the older model, it's always open. This one, oops, wrong one. This one is open also to let fresh air into the canister to push the vapors out to be purged through the intake to be burned. But with this system, you have to check for leaks. In order to check for leaks, it has to close this valve. This only time that the vent valve is closed is during testing. They test the system for leaks. So when the purge valve opens up, it pulls the system into a vacuum. It can't pull into a vacuum if the purge valve is open. So the purge valve, it can't pull into a vacuum if the vent valve is open. The vent valve has to close. Purge valve opens and pulls the system to a vacuum. On top of this tank right here, they got the name wrong. It should be fuel tank pressure sensor. It can watch the tank in inches of water to see how far it pulls into a vacuum. The PCM will watch this fuel tank pressure sensor here. So when this vent valve closed, the purge valve open and pulls into a vacuum, it can tell by watching this sensor here. This sensor is usually on top of the tank and usually reads inches of water. And it goes back to the PCM. Here's an electronic purge valve on the newer models. And here's a canister, here's a Toyota canister. Air injection. purpose of air injection system is to reduce HCs and CO. On some of the newer cars, though, let me back up. The air pump, air injection system, AIS, air injection reactor, whatever you want to call it. Its job to reduce HC and CO. It works from the car's normal operating temperature. It directs air into the intake manifold, upstream, or to the catalytic converter, mid-bed, downstream when the engine's at operating temperature. Now keep this in mind. Some of the newer cars, the air pump only works when it's cold. Then it turns off. The early air injection system is used to oxidize AC and CL. When it run an engine risk to pump air into the exhaust system. Like I just said. The secondary air injection, primary, is for early converter operation. Also oxidize AC, also oxidize CO, which is rich, cold engine operation. Like I said, some of these new cars, they only work when it's cold. I think on the test they're going to actually buy a newer car air pump, not the older one. The earlier air injection system has a pump, uses belt driven for air supply. Then some systems have pulse type that works off intake pressures. Here's the early air injection system. This has here's your air pump, here's the air hoses, here's your check valve, here's the air distribution tube that feeds air to each runner. The pump draws in air, has suspenders that draws air into the system. It's another version of the air pump and injection system. Here's your air pump again. Your diverter valve. The diverter valve controls airflow from the pump. See, here's the air pump. Here's the hoses. Go to the diverter valve. The diverter valve directs the airflow through a check valve into the air distribution tube to the manifold. The check valve lets air goes in one direction and not the hot exhaust back this way. If the hot exhaust went this way, reverse flow, hose, valve, and the pump will burn up. So when these go bad, they either go clogged up, reverse flow, or make a lot of noise. Like it has that exhaust leak. Let me see here. Early air pump again. Here's your air pump. The diverter valve directs the diverter valve directs the airflow into the manifold. The diverter valve also directs airflow into the intake and the other side of the manifold. Early air injection utilizes a diverter valve to control air delivery location, like I said earlier. So the diverter valve controls the air flow or air delivery at certain locations. Air pump check valves, like I said earlier, they let air go in one way to the manifold. The hot exhaust is going this direction. The check valve stops them from going backwards, reverse flow. When they go bad, they let the air, one is the exhaust leak, or the hot exhaust goes back to the air injection system, burn the hoses, the valve, the pump, or they get clogged up. That's the three symptoms that go wrong with the check valve. It's a reed valve system, reed type check valve. You can see this little door right here where air is going this way and negative pressure, but positive pressure closes the door, as you see here. It's a pulse system. You don't see this one that often. It's a pulse type system, no belt. You use a negative pressure to pulse air from the intake into the intake. It's like a Toyota. Here's your post air injection system on the side of the Toyota air cleaner. That's the air cleaner. That's the post valve on the side of it. Here's the hoses going to the either to the intake air or air cleaner. This is the one that bar takes off the car too and send it to a smog shop to see if you catch it. That's one of them they use. Computer controlled air injection. Here's the pump, closed loop. That's the engine, that's the pump, that's the belt. Controlled by the ECM. The solenoid here. And this on this car here, the burr valve or port solenoid they call it, sends it down here past the check valve into the exhaust and either into the mid bit of catalytic converter or upstream to the manifold like this one here. It goes this way on the cold engine or down here to the mid bit of catalytic converter when it's warmed up operating temperature. So in cold start it goes up here. When it warms up and goes in closed loop, it goes down to the mid bit of catalytic converter. Location of air injection upstream to cylinder heads or manifold only during open loop operation. When it goes in closed loop, it goes downstream to the converter during a closed loop operation. And some cars actually dump the air to the air cleaner to prevent backfiring. That's on the earlier models. Here's the secondary air. Also, the newer version. On the newer cars, the functioning air pump, the vehicle starts, ECM determines coolant temperature and intake temperature are cold. The ECM triggers the secondary air pump relay, which powers up the pump and gives a ground to the secondary air solenoid. Intake vacuum travels through the secondary air solenoid to the diaphragm in a Kobe valve, pulling it open and allowing flow through it. So basically what they're saying is, on these newer cars, this is operated when it's cold. And once it warms up, it turns off. Here's the electrical air pump you see here. This is the one that operates cold only. And here's a secondary air controlled by the computer. Air route switch, air going to air injection to the manifold here before it gets to the cat upstream, here and here. They're showing air going upstream on a cold car, here and here. They're not showing you when it goes downstream when it's closed loop, which is odd. Oh, I take it back, because this must be the newer version. They only send air to the manifold when it's cold. That's why not going downstream to the cat. Here's some secondary air valves. The air location, here's the air, got the air pump, check valve, and power control module. EGR. The job of the EGR system, exhaust gas recirculation, is reduction of NOx. The purpose of the EGR valve is to reduce NOx. It adds inert gas into the combustion chamber and slows down the burning process and lowers the temperature. Its job is to keep the combustion chamber temperature below 2500 degrees Fahrenheit. If it can do that, it helps lower NOx. Fuel mileage, the inert gas takes up volume that would have been air-fuel mixture. It actually takes up air, actually displaces oxygen. The less O2 you have, the slower it burns and the heat goes down, reduces NOx. EGR system: functional, vacuum control, conventional, internal back pressure, and external back pressure. All EGR valves work at cruise speeds. Okay, all EGR valves work at cruise. Computer control EGR valves. They may be vacuum operated, they may not be vacuum operated. They might just be electronic. Here's a conventional EGR valve. I get ported vacuum here. The valve stem lifts. It lets inert gas into the intake system, which goes into the combustion chamber. It takes up space from oxygen, and that cools down the combustion chamber to prevent NOx. Here's another picture of one. Intake manifold EGR. Ported vacuum here. On this side here, I got exhaust gas, and on this side here, it goes to the intake port, manifold intake port. A conventional system, I get ported vacuum here. This pintle lifts up. The exhaust gas flows past the pintle into the intake and finds its way to the combustion chamber. When I lose vacuum here, this is a spring that pushes the valve closed again. Now, internal back pressure EGR valves has a bleed right here. In order for this one to work, once it gets to ported vacuum, for this to work, this bleed has to be closed. So they will need back pressure to push up here on the diaphragm to close this internal vent. Without the back pressure, the valve doesn't work. Now they got external back pressure EGR valves right here. It's a back pressure modulator. 2 signals from here, exhaust port from here, and this valve going to a solenoid, and from the solenoid it goes to the EGR valve. I think that's a Toyota. And here, this is another one on the GM. You can see the solenoid, a sensor is on top. That's the EGR valve right here. This goes to the exhaust port here. And the back side, this goes to the intake. You can't see it, but the back of this goes to the intake. And here's your back pressure transducers. You find some manufacturers use. Toyotas, Mazdas, Mitsubishis. Here's a computerized control EGR valve. It's a differential pressure feedback EGR system. It's controlled by the computer. Here's the valve. Here's the EVR, EGR vacuum regulator valve. Helps control the opening of the valve here. And here's your back pressure sensor to tell the computer the position of the valve, or if it's even flowing, by this little drop right here. This pressure drop. This little orifice right here. It checks for a pressure drop here and feeds that signal back to the PCM to notify the PCM if this port is cleared or not, if the valve is working. Electronic EGR valves. You see here, no vacuum line, all controlled by electrical solenoids. Now in these type of EGR valves, you can actually use a scan tool to test them, because they had no vacuum lines on at all. It's all electronic. And here's an early EGR valve, and it has an EGR cooler, helps keep the gases cooled down. I forgot to say also, that's a digital EGR valve. I use a scan tool to test it. Oops. Okay, that's it for that. I'll see you in the next one. If you got any questions on that, let me know. I know it's a little longer than the rest of them, but I'll try to get as much in as possible.